So in this video, I'm going to talk about L'Hopital's rule with the indeterminate form 0 times infinity. It's important to note that this infinity could be either positive infinity or negative infinity as long as it is some kind of infinity. So what we want to do with L'Hopital's rule, it does require the use of fractions at some point in some way for doing the limit. So what we're going to try to do is if we have a limit as x approaches a of two functions being multiplied together, one of these of course goes to 0, the other one goes to some kind of infinity. What we're going to do is we're going to try to turn it into some kind of a fraction with one of those functions. So for example, I might turn f of x into the denominator by writing it as 1 over f of x in the denominator, still have g of x in the numerator, or I could do it the other way around and we could do f of x over 1 divided by g of x. So that's kind of the trick here, is taking one of the functions and turning it into a fraction by writing this 1 over that function. So hopefully this will kind of get us prepared for what we're going to do with our first example. Our first example that I'm going to do is the limit as x approaches 0 from the right of x times the natural log of x. So a couple of important things to note about this one is we do have to do 0 from the right, because the natural log of x is only defined on the right side of 0. You can't plug in any negative numbers there. We could also need to just double check to make sure this is the correct form of the indeterminate, so that we are using the correct method. So I would just think about it from this perspective. If I look at x approaches 0 of just the x by itself, that would head towards 0. And if I look at this function ln of x, the natural log of x, as it heads towards 0, it's heading toward negative infinity. So we do have this, of course, form of 0 times negative infinity, which is what we are looking for in our indeterminate form. Now that I've just verified that this is, in fact, the correct indeterminate form, I'm going to go ahead and start working on finding the limit using L'Hopital's rule. So what I'm going to do is try to turn one of these into a denominator, into a fraction. And so if I think about it, the natural log of x, it's not going to easily turn into a fraction. However, just x by itself would work out kind of nicely. So I'm going to rewrite it as limit as x goes to 0 from the right of the natural log of x divided by 1 over x. Now, I might also, and I think I'm going to do this just to make my life easier when I go to take the derivative, is I'm going to rewrite that 1 over x as x to the negative 1. And so it might make it a little bit more obvious to you at this point that in this situation, this is in fact equivalent to the original limit, because if we have a negative exponent in the denominator, it tells me to move it to the numerator. So I would go back to the x times the natural log of x. But so now I'm ready to apply L'Hopital's rule, which says, again, take the derivative of the numerator, take the derivative of the denominator, and see what happens. So we're going to take the limit as x approaches 0 from the right of the derivative of the natural log is 1 over x. And the derivative of x to the negative 1 using the power rule is going to be negative 1x to the negative second. I am going to rewrite this 1 over x as x to the negative 1 just to make my exponents a little bit easier to deal with. And I'm just going to remember I could probably go ahead and just take out this negative, or I'll just leave it there for a minute and deal with it in a second. So I'm going to focus on these exponents for a second. Since we are dividing, we would subtract. Negative 1 minus negative 2 is going to make a positive 1. So we have the limit as x approaches 0 from the right of x to the positive first, divided by essentially negative 1, so that's just going to make it a negative. Like I said, x to the negative 1 divided by x to the negative 2, we subtract the exponents, get a positive 1, divided by negative 1 gives me that negative. And if I take the limit as x goes to 0, this is just going to turn into 0. And so that's going to be our final answer for L'Hopital's rule in this question. All right, so now that I've handled that example, we can move on to the next example, which is the limit as x approaches negative infinity of x times e to the x. Again, I just want to verify real quickly that this is in fact the indeterminate form I'm looking for. So if I were to try to focus on this x for a moment, as it heads toward negative infinity, it's going to be negative infinity. And as e to the x heads toward negative infinity, that goes to 0. So again, I have this situation where I have infinity times 0, so this is the correct indeterminate form. Now in this case, I'm going to be a little bit more careful in which one I choose to be the denominator. And the reason I say that is because if I choose this x as my denominator, and I'll just show you real quickly, if I choose that x to be my denominator, we'll have e to the x divided by x to the negative 1, and I try to apply L'Hopital's rule. The derivative of e to the x is e to the x, and the derivative of that is negative 1 x to the negative 2. Well, that's not making it any better. That's not making any improvements here. And if you continue to try this method, you would still keep getting kind of the same answers of e to the x on top and some x exponent in the bottom. So like the next one would be 2x to the negative 3. So it's only just kind of making it worse going in this direction. So instead of choosing this method, and I'm realizing it's not working, what I would try to do is let's try making the e to the x the denominator. So I would write it as x divided by e to the negative x. Now, when I take L'Hopital's rule, so again, I don't want to do this. When I take L'Hopital's rule of this, the derivative of x is just 1, and e to the negative x turns into negative e to the negative x, which if I really wanted to, I could rewrite it as negative e to the positive x, because again, you have a negative exponent in the denominator, it moves it back up to the numerator. Well, so if I'm making that head toward negative infinity, it's still going to head towards 0. So that's kind of the key thing here, is just being careful of which one you choose. If you choose one and you're starting to get really weird answers, maybe try switching and doing the other one. It might make things a little bit easier. So I'm going to go ahead and move on to my last example now. Notice it's the same problem, x times e to the x. The only thing I've changed is what the limit actually is of. And again, this is kind of the important part of why we verify the indeterminate form. So if I check, x is going to positive infinity, so I'll write that down. But e to the x, as it heads toward positive infinity, is also going toward positive infinity. Well, if I multiply positive infinity times positive infinity, we just get positive infinity. So this question does not, in fact, rely on L'Hopital's rule at all. I can just check and see what happens, and I don't have to use L'Hopital's rule. It's just positive infinity. That's the final answer. Hopefully this helps you guys better understand this particular indeterminate form. Let me know if you have any questions.